So this is our 3D prototyping lab. It is part of the Fab Lab that we just saw, but it's also more for curriculum. So we have engineering technology as well as CAD programs here on our campus, and both of those deal with computer software to design something new. What these machines allow us to do is to take a 3D object or 3D model that you would see on the computer, and until we got this equipment, all you could do was really spin that around and do simulations, but you couldn't hold it. Now with these, we can actually print them out. So what happens is with each individual piece, you would send that information over to the printer. It moves back and forth, lays down layers of plastic or resin, and then a UV light will cure it with each pass. So you can, what's called additive manufacturing, you can use additive manufacturing to design or prototype new parts. A traditional prototyping or manufacturing is taking a block of something, say aluminum, and removing all the junk you don't want. This, you start with nothing and only build up the parts and pieces that you want. So we have several different types of machines. The ones on the far left over here actually print in PVC plastic. This stuff looks a lot like weed eater string whenever it comes out. And this is PVC, the stuff that they make water pipes out of, so pretty strong. Most of these machines are intended for prototyping, but you could use that for, actually use it for something. The machine right here, the Alaris, prints in resin, so it's a vat of liquid that is laid down and then a UV light cures it. And the far machine over here, the one that's gray, actually prints in color. So this is the way that it actually looks when it comes out of the machine. This is not a multimeter, it's just a piece of plastic. But so not only form and function that you can check, but also aesthetic, what it's actually going to look like. Here's another prototype of a little button here. One of the other cool things that we've got in this lab is a 3D scanner. So this piece of machinery will allow you to put really any object in front of it and scan it in 3D space. This is a deer skull that our instructor found out in the woods, scanned it when they got this machine calibrated, and reproduced it in a smaller scale. Now there are more practical uses than recreating dead animals. Yeah. But it kind of gives you an idea of the amount of detail that we can.
So this is the scanner then?
Yeah. And this type of technology is used quite a bit. So like the Sphinx in Egypt, they put a bank of these on a huge trellis that went across, and then every year they run it across and take a 3D scan of it, and then they can tell how much it's eroding over time and what they would need to do to protect it. So, again, this is part of the Fab Lab. If you're a member of the Fab Lab, you would have access to this. You have to pay for the material and just enough to cover the cost of running the machine. So if you're a company, you can come in and have access to these machines. More than likely, we will try and team up a company with one of our students so that they're actually getting some experience working on a real-life project. So if there are companies that want to prototype something new and are not under a huge time restriction, that's the one thing about education. It takes a little while to learn things. But if you've got a project that you want some help with, our students are looking for cool projects. Any questions about this program? Yes, it did. Yeah. Oh, yeah. Oh, yeah.
There's some more advanced stuff.
Some fancy one, and one has like 14 miles on it, and the other one has like 4 miles on it.
Wow. What did you say the relationship was between you and Harley again?
We do assessment training. We do assessments and training for Harley General Motors and Ford. So Harley specifically, if they hire anyone new, they come to our facility for assessment. But a lot of times Ford and General Motors, if they've got a new group of employees who need to work on pneumatics or PLCs or whatever the case may be, they'll work with them in that facility, as well as doing assessment for their employees too. So it's both educational and kind of a testing facility.
Okay.
Alex, generally, what are the assessments entailing, or including what kind of assessments?
They've got an assembly area back here that's exactly the same as they have at Harley. So their time in building and putting together a handlebar is one of the assessments. So it's just a blank bar, and they have to put all those.
Which sounds like the two tests, basically.
Yeah. have a bunch of different labs over in the other wing that are specific to, let's say, industrial electrical or hydraulics and pneumatics, but each individual room has a separate purpose. This is kind of the capstone room where all of those things culminate into one idea. So we have our industrial electrical, which is the actual hard wiring. We do PLC training, which is the brains of an automated operation, hydraulics and pneumatics. This machine's over here, this blue machine was designed by BTC folks, built, then sent to Harley. We trained their folks how to use it, and this was built with the intention for the 100th anniversary to stamp the emblem on either side of the gas tank. Then year 101 came about, and we got it back as a training tool. They didn't have any use for it anymore. So our instructors put a toggle switch on the back, and they mess it up. So our students have to figure out what the problems are and what they would do to diagnose it. This piece of machinery was donated by Bayer, and I don't really know everything that it does. I know it moves liquid around, it heats it up, it cools it down, it mixes things together. But from what I'm told, it's got operations in there that we wouldn't, A, be able to afford or be able to find. So it allows our students to work on things that are in industry but just aren't available on the market anymore. And then this machine is our newest simulator. What happens with this is students in different curriculums. So let's say it's a programmable logic control student with an engineering technology student or any combination would be assigned an individual cell. So they would have to calibrate and set up their individual cell, but also work with the other teams to make the entire process work. Now, when this was first set up, they gave me a tutorial on how to start it and make it work. Then the last time that I tried it, everything started beeping. So today, we're just going to get a manual walkthrough. So what happens is this little bar will come over and pick up one of these cups. It's then measured against this. Moves down the little slides, got holes in it like a little skee ball table. Is that what it's called? Shuffleboard.
Air hockey.
Air hockey, that's the one I'm thinking of.
Looks like the old mousetrap game.
Yeah, it does.
This is a carousel that's a simulated deburring area. Moves down the conveyor line with different sensors and then kicked into the individual slides. The robotic arm will then come over, pick one up individually, put it in this little staging area, grab what I'll call a piston, I don't know, and a spring and a cap, and it makes a little multi-component widget. Now you cannot put I can make multi-component widgets on your resume, but this is the same thing that they have at the Postal Service, that they have at where they make ketchup or tires or whatever. I mean, it's all the same sort of thing, applying it to different purposes. This is a simulator we had for a couple of years prior to that. It takes washers that are some aluminum, some plastic, some black plastic. Some have holes, some don't have holes, and it separates those into the different cups. So essentially the same thing if you do in an industry, just a little bit smaller scale. Questions about any of this stuff? I will mention that one of the reasons that we get away with charging $92 per credit hour, which is, I think, probably obviously not enough to cover the cost of everything we've got here, is that we're subsidized by taxpayers. Property taxes help to keep our doors open. So that's one of the reasons we get away with a program that probably costs $20,000, but only charge $15,000. So this is, again, part of the HVAC lab. We use these kind of practice boards in lots of our programs. So students are given a box of parts and some schematics and told to turn it into an air conditioner. Other times these are all wired and charged, and they have to go through and diagnose and fix the problems. As we go around the corner here, this is commercial refrigeration stuff. Students who are going into the associate's program, they get into quite a bit more commercial refrigeration, but essentially all the kinds of equipment you would find at Applebee's or Days Inn or whatever. So reach-in freezer, ice maker, ice cream maker, sandwich area. We've got 3 walk-in coolers and walk-in freezers. I don't know which one's which, but simply the same thing you'd find at a restaurant. We do have a stationary engineering program as well, which is more about building systems. So, Bartle Hall has problems with the AC. They don't call AB May. They just employ someone And that's the kind of program that we're talking about here. So automated lighting, heating, cooling, some security, those sort of things. And then all these machines back here are all fully functional, just like at your house, except our instructors mess them up, and then students have to diagnose and fix the problem. This is our sheet metal lab, part of the HVAC program, where students take sheet metal and make the ductwork move air throughout your house. So those high school geometry classes that you thought, I'm never going to use this, they're using it right here. Also figuring airflow, so you get a certain amount of pressure coming in this side, how much do you expect? Different brakes, spot welders, rollers. The door that's open back there, that's a stairwell that goes up above us, and everything above us is just studded walls. There's no sheetrock. That's our house, essentially. So students who are going through the associate's degree program, their capstone class, they are teamed with one other student, and they build a fully functional heating and cooling unit in the upstairs. They run all the duct work. The wiring stays, but everything else is installed each time. The instructor goes through and checks everything out. If it's good, they tear it out, and the next group goes in and does the exact same thing. Questions about any of this? So the machines that are in this area are all new technology. These are geothermal heat pumps. The big spool of PVC gets buried underground, and then that pumps fluid through to either absorb or transmit heat into the ground. And then the machines kind of behind us are all just new units. There's some that aren't even unboxed yet. We've got a unit that's going in that will actually run on solar power, and the solar panel will tilt towards the sun as it moves across the sky. So that should be installed early in the fall. And then over here is the real, nuts and bolts of the whole deal. As I mentioned, our instructors work in industry. They bring back these machines that are beyond cost effective to repair. And then our students tear them apart and make them work. Because realistically, when you get out and working in this industry, the majority of stuff you're working on is old and junky, and that's why it's broken, and that's why you got to be there. So thoroughly understanding how this age technology works and being able to diagnose and fix that is pretty important. Over here, some air conditioning units that have some age on them as well. Before we see the rest of the HVAC, we're going to walk out here and see the Line Tech program.
Alex, do companies donate equipment?
All the time, many of our programs, like that equipment upstairs, Bear and Harley.
Yeah, I heard you say that. So air conditioning units here?
Yeah, most businesses that would have air conditioning would be too big for us. So a lot of these just are residential stuff. Now, we do have some commercial refrigeration things that we'll see in just a minute, and those were donated by local businesses. They were broke at the time. They just wanted to get rid of them, and our students fixed them. So this is our Line Tech pole field. This is actually the lab where these students work. All of our programs, you spend about 50% of your time in the classroom with theory and safety, and the other half of your time is out in the lab. So students are out on amazing, beautiful spring days like today. Also, when it's nasty and cold and raining, it didn't make any difference. They're coming out here anyway. So our students dug all these holes, set all the poles, ran the lines on the top, and because they're used so often, these poles have to get replaced. So our students get practice driving these trucks. We got 2 trucks here and another one behind the fence over there. They drive the trucks, they dig the holes, they set the poles. Again, everything that they would be doing at a utility company, this allows utility companies to hire people that have the ability to be a productive part of the team from day one. The way that they used to do it, companies like Kansas City Power and Light would hire people who were green, had no experience, and then they would train them through the whole process of climbing pole and safety and all that sort of thing. Well, that, when you've got a 20% dropout rate, just making it through the initial portion, just making it through, let's say, the first week of training, not the best way to go about it. And so they realize they're not an educational facility, they're a utility company. And so utility companies across the U.S. have asked community colleges to put these programs together. Again, 1 year and then 4 to 5 years of on-the-job. This is our Fab Lab. This is a laboratory that's filled with equipment that really existed on our campus even before we opened this, as you might imagine. Not every piece of equipment is used in every semester, so some of it sat in storage. So this lab was opened up as a way to consolidate all this equipment and allow students to come in here and work on whatever they want. There is no particular curriculum that's taught in here. This is all for extracurricular type of stuff. So a currently enrolled student can come in here and join the Fab Lab for $50 a semester, which is about 4 months, or anyone from the community can come in and join the Fab Lab. We charge outside people not taking class $50 a month to join the Fab Lab. But you get access to all this equipment. Behind the petition, we've got some robotics, electronics equipment. We've got a small paint booth, a laser engraver. This is a CNC plasma cutter right in front of us.
And do you have people that show you how to operate?
If you don't know how to operate this, we can give you a tutorial. Now, you have to pass a safety exam with each one of these pieces of equipment, as you might imagine. So what that amounts to, let's say you wanted to use some woodworking equipment. You would come in, you would do an online reading, you would take an online assessment, then you would come in and show us that you know how to run the equipment. So we would give you a project, let's say you build a birdhouse, and we supervise pretty close and make sure that everything's gonna, you're not gonna cut your fingers off. There's also always someone in here that no one's ever gonna work alone. Mm-hmm. It's open Monday through Thursday, 11 to noon, and we'll be opening on Saturdays in the near future.
So how old do you have to be to come work here?
If you're the first robotics students that we saw earlier, they come in here and work, but again, they're supervised. We've had some groups of, I'm just joking. This is our welding lab. Pretty much everything you'd see traditional welding that would be needed in the Midwest in this area. So oxyacetylene cutting. We've got, as we saw upstairs, some CNC plasma cutter. A little bit of automated cutting machinery back there, as well as some pipe cutter for pipe fitting. 24 booths, all pretty much set up exactly the same. Stick welding or arc welding, MIG, and then TIG as well. We don't have a TIG gun out here. That's kind of the two-handed process, really pretty stuff. So TIG, which I don't have an example of, would be a bicycle frame.
I'm doing TIG.
Do you have the TIG
Yeah,
gun out?
I'm setting up the torch right now.
Awesome. So she's going to show us the TIG in just a second. MIG is going to be used in all kinds of industry. I mean, really, anything that you can think of, from making dumpsters to that. It's going to be used. Arc welding, it's been around for a long time, and it's used a lot in outdoor type of stuff, but it's kind of dirty and nasty compared to this one. Now, it's all dirty and nasty, but in relatively speaking, this has a lot more smoke and stuff that flies off the side. Questions about any of that part? As I mentioned, students earn AWS or American Welding Society Level 1 and Level 2 certification. So this is general certification and industry-wide. If a student were to graduate on Tuesday and Thursday and move to Honolulu or to Atlanta, that piece of paper that they earn from American Welding Society is the exact same thing they would earn there. Now, there are specialized AWS certifications that you can earn, say, overhead weld or something of that nature that would be specific to the type of company that you're working at. But this certainly shows that they have a really good grounded understanding of what's needed in the field. These are the machines that they use to test some of the welds. Weld two pieces together, put that seam, and then drag it down. And if it bends into a U shape, you pass. If it corrects, you keep trying until you get it right. Questions about any of this stuff?
Are you typically at capacity with students on this?
No, we usually have a few open seats. This is not a cohort program, it's an a la carte program. So some semesters are, beginning classes may absolutely be packed. The next semester we may have 10 open seats. It just, maybe there is a scientific reason. I don't know. My hypothesis is there isn't.
Well, I'm excited to do another meeting. Thank you so much.
Very nice to meet you.
All right, as I exit, left.
Go out the door to the left.
Okay.
You came in the east entrance, right? Not by the Harley Davidson?
Right.
Right.
Thank you. Nice to see you. Thank you.
Anyone have any other questions about any of the stuff we've seen?